Hello everyone, hope you are all okay and doing well. Today we are going to test three assembly programs over KEIL software. The first program we are going to see the most addressing modes that we saw in the semester, which contain direct, immediate, indirect, and register addressing modes, and some arithmetics and logics command and exchange the orders and extra. In this program we are going to start from org00hex, which is our standard starting area when we are coding, and the first four lines we are actually giving initial values to some registers. The first, when we said move 00hex 0f hex, which means we are giving the register 00 hex, which is register 0 of the bank 0 the value f1 hex, and the same for 0 hex 08 hex, actually 08 hex register, which means it's the register 0 of the bank 1, this time the bank 1 equal to 02 hex value, and same for this line. It means the register 20 hex contain 30 hex value, and the register 31 hex contain 10 hex value. We gave those register the giving value. It's our initial values actually. Let's run the program. First of all, we need to translate it to ensure there is no errors, no warnings. Then we need to build it, then rebuild it to ensure that everything is okay, and then we can run the program. When we run the programs, we got this windows which contain the values of the registers from R0 to R7, and the accumulator and the B register, and the programs that sorts. Also, if we see this kind of problem, you can solve it by using reset. So now you can see the value of the arrays and the carry and the parity. So if we test it now, test the program, so first line there is no changes. Now the R0, it took the value f1 hex, it is the same like we gave it here, and now we will see no changes till we go to and we will do and logic in the programs that sort with the value 0, the 0e7 hex, which means here, let's see the changes in the programs that sorts. So in this we had the 000 value, which means we are in the bank 0 area. So since we are in the bank 0 area, A gonna take this value since we are in the bank 0 f1 hex. And if you see here, so it's exactly in the took the same value here, and as you notice here, the parity of the programs that works to the value 1, which is related to the number of ones in the accumulator. Since it's odd number of ones, so the parity 1, otherwise it's 0 when it's even. Now in this line we are clearing the carry, which means it's 0, so it's already 0, and in this, so it's 0 as it was 0. In this line we are adding 40 value, 40 data to the previous A of which was f1 hex. Let's see the results. It's 31 hex. That's mean a 31 hex. And now we are moving the value of carry 31x with the carry 1. We are moving the value of the carry to the 0000 hex bit area equal to 1. As we can see here, the 00 hex in the bit area, it's exactly in this area. Since it's in this area, so the value and the data of the register will change from 30 to 31 since we add 1 to the value. So we need to write the new value of 20 hex. We're gonna add it 1. So since it was 30, now it's 31 hex. And now we remove the value of A since we are in the bank 0. So 00 hex. We are in the bank 0, so it's R0 bank 0 equal to the value of A, which is 31x. Let's see if it's right or not. So as you see here, it took the same value. So the F1, move it here, and now it's 31, same value as A here. Now in the second line, it's indirect addressing modes. So we'll see the R0. What is contained? It's contained R0 of the bank 0. It's contained 31. We will consider it as an address. When we consider it as an address, we need to go exactly to the 31, which is here. It's 10 hex. It means I will take the value 20 hex. Let's see if it's right or not. Yes, it's 10 hex because it's indirect addressing mode. So we'll consider the value of the register 0 as an address. We'll go to this address, take this value, put it in the accumulator. Now we are doing our logic of program stats forwards with the data 0 hex. Let's see the new value of the program stats forwards. Since we have RS1, RS is 1, so it means we moved now to the bank 1. Now we are dealing with the bank 1. Don't forget to consider all the value of the bank 1. So b equal to R0 of the bank 1, R0 of the bank 1. As you can see here, it's 2 hex, as you can see here. So it's 2 hex. Let's check it here in the program. So it's 2 hex, and it's right. Now we are multiplying A and B. Since we are multiplying, so the integer number can go to A. Now it's 20, and the B gonna equal 0. Let's test it. Yes, the value of L 20, and the value of B is 0, and the parity is 1, and the carry is 0, and RS is 1. Since we have an odd number of A, an odd number of 1s in the accumulator, so the parity is 1. And now we are moving the value of A to R0. So don't forget we are in the bank 0, bank 1, sorry. So the same value as A is 20 hex. And now the value of A, go to the R0. R0, we are in the bank. Now we are in the bank 1. R0, it's at 20 hex. Go to the 20 hex. 20 hex here contain 31 hex. So A gonna equal 31 hex. So you have to put the comma, so because it's explanations. Now R0 is equal to 20, as you can see here, same as we did here. And the other step, A equal to 31. 31 is the same value as you can see here, it's the same. So our thoughts all right. And now we need to do XOR with the data 34x. Let's see the results. So in this case, A gonna be equal to a equals to 5x, as we took this value. Now we are moving 00x data to the program stats forwards, which means we move to bank 0 again. Let's test it, and this value gonna change to 0. Now it's 0 and we are in the bank 0. Now we are going to move the value of a to the R1 of the bank 0, which means 01x equal to, what is the value of a? It's 05x. Let's see if it's right or not. Yes, the R0 of the bank 0, it's 05x, and we're on the bank 0 as well. Now we are giving the 02x value, and let's see here. So the b, it took the value 2, and when we are dividing a and b, so 5 divided by 2, it's supposed to be a equal to 2 and b equal to 1. Let's see it. Yes, a equal to 2 and b equal to 1, and the parity is 1 since the accumulator have an odd number of ones. And now we will move the value of b to the R0 register. So the R0 register 00x means we are in the bank 0 equal to 1. And now it's in direct addressing mode again. You will see the R0 it's contains 01 and the 01 contains 05. So we'll consider it as an address. Go to this address and it contains 0x data. Move this data to the accumulator. Let's see here. Yes, the R0 is 1, the same as our results. On the second line, the A is going to be equal to 5. And now the parity is 1, the parity is 0. Sorry, since the accumulator have an even number of ones and no changes in the program stats forwards. We are still in the bank 0. And then we are going to rotate left the accumulator. Let's see the new value of A. So it's 0ax. Now A can equal 0ax. Sorry, 0ax. And now we are going to exchange the value of A with the value of register 1 of the bank 0. So A is 0a and the R0 is 05. So we'll change this value with this value. So 05x for A and R1 equal to 0ax. Let's see. Yes, exactly. So the value of A after exchanging those two values, R1 equal to 0a hex and the A 05 hex. Now we are going to use the order exchange D, which means we are changing just the low part of the register. Since we are changing just the low part of the register, so first of all we'll go to the value R0, consider it as an address. So R0 here it's 01. It means we are in the register 1. So register 1 it's 0a hex. We'll change just the low parts of those two registers. So A gonna be 0 the same and a hex, and R1 gonna be 05 hex. Let's see here. Yes, exactly, the R1 is 05 and A 0a hex, and it's the end of the program. Now let's try to solve the questions under this. So he said, after executing the ninth line, what is the value of R0? Since we add some initial values, we need to remove it just to keep the lines. Yes, since we are in the ninth line, what is the value of what is the value of R0? The value of R0 now, let's do it like that. Yes. The value of the R0 is 31x. So, sorry, 31x, it's the right answer. The second question, after executing 13 line, what is the value of a 13 line here after multiplications? A gonna be 20, so a gonna be 20x, and this is the right answer. The third one, in the 10th, after executing 10th line, what is the value of a 10th line? It's 10x, and a equal to 10x. Now, after executing the 8th line, the value of 0x bit area, it was 1. Yes, bit area 00x bit area equal to 1, and you can put 1. This is the right answer. The 5th, after executing 20, did the value of b 20. So 20 line, the value of b is 1. So the value of b 1. That is the right answer. After executing 20th line, the value of a 20. Let's see. 20th, the value of a, it's 2. A, it's 2. As you can see, you can solve it so easy after executing the program one by one, no problem at all. After executing 5, the value of a, let's see, 5, the value of a, f1x, 5 f1x. Oops. Yes, it's the right answer. Excellent. Now, after executing 17th line, 17th, which one is, let's see, there's 17th. 17th, we are at the bank 0. Bank 2, no, we were in the bank 0. So, this answer was the right one. Now 14, take the value of R0. Let's see, 14 R0 was 20. Do I have 20? Of course we have. So this one is the right one. Now the 25 line, take the value of A. 25. Oh, is it 25? Yeah, 25. 25, the value of A, 0ax, 25, 0ax, okay, 0ax, the right one. Now, 18th line, the value of R1. 18th, the value of R1 was 0.5x. It means 5x, the same. And now, which of the following operations take place after executing 4 lines? Let's see first the 4 lines. 4 line, bank 0 is 0. The bank 0, choose the bank 0. after doing logic, the data 0E7X, and what we have choices. It's Turkish. Value of SP is changed. No. Or generating. No. The BC is loaded. No. Yes, this one is the right one because we chose the bank 0 during the end operating. Now after executing 25 to 24 line, what is the value of A? 24, let's see, 24 line, 24, the value of A was 0.5x, as you can see here. 24, value of A, 0.5. 24, value of A, it's 5. Excellent. Let's see the next question. 14. Now after executing the 15th line, what is the value of A? 15th. Let's take the 15, this line, value of A is 31. Okay, 31. Excellent. Let's see after executing 16, what is the value of A? 16, value of A, 5x. So easy. After understanding and writing the program over KEIL software, everything will be easy, no problems, no wrongs. It's right 100%, so no worries. After executing 7th, what is the value of A? 7th, value of A, 31. Yes, 31 again, another 31. Yes, that's right. Now after executing 25, what is the value of R1? On the line, 25, R1 was 0.5. 0.5 means 5. Yes. And it's right. And now 22. What is the value of A? 22, the value of A, it's 5 again. We have a lot of 5s. Yes, 5x. Now all the end of program, what is the value of, at the end of the program, what is the value of 01 hex byte address? 001 at the end of the program. Let's see, in the end of the program 01, it's 5. You can take it from here and you can take it from here as well. It's the same here. It's asking about the R1 of the register 01. It's mean R1 of the bank 1. So you can take it from here. It's 05 and you can take it from here. So it's 5 again. We have a lot of 5s, really. Yes. No, this one is the right one. The last one, after executing 23rd line, the value of A, 23. 23, A is 0AX. 0AX. And that's all. So it's the end of the program. We solved, as you can see here, we solved all the questions easily after writing the programs, and you can save it here, no problems, everything is okay, no worries. You can be sure 100% from your answer after writing it to KEIL program, and all the answers is right 100%. Thank you for listening and wish you all the best. See you in the next program. In this program we need to clean the memory or registers from 2 hex till 20 hex by using decrease jump not zero command. What we need to do exactly here, we need to clean this size of memory from 2f(x) till 20(x). So we need first of all to know how many times we need to move during the register. First of all, we need to know, so we are dealing with the hex, so 2f(x) minus 20, so it's 15 decimal times, but since we need to clean the 20(x) memories too, so we need to move 16 times, so we will move from 2f(x) till 20(x), and we will clean the 20(x) and stop in this size of area. That's what exactly we're doing here. So the first line of the program, we are moving the R1, which is our counter, we are this label gonna be repeated 16 times, and during the 16 times we are going to clean the registers from 2f(x) till 20(x). And now in this label, in this line, we are giving the R0, so it's our starting area. We need to start cleaning from 2f(x), so it's 2f(x). So and then let's run the program and note all the changes. So after running the program, we can know if we are working right or not. So the R1 is 10(x), which means when we gave, so if you add the decimal, so 16 equal to 10(x), it's all the same, 16 decimal 10(x), whatever, it's all the same. So in the next line, we are moving, we are using indirect addressing modes. So we'll go to the R0, consider it like an address, go to the this address, go to the 2f(x) address and give it the 00 hex data, and you can see it from here as well, 2f(x), and see it's all 0, so you can see all the changes from different size as you like. And now we are decreasing in this step, we are decreasing the R0 because we are using to clean 2f(x) and then 2e, yes, decrease, so the next step it's 2e, so now R0 will be equal 2e hex. And now in this line we are going to decrease, we are using the order decrease and jump if not 0, so we need to decrease our counter, since we are using need to use this label 16 times, so every time we'll decrease 1 and go again to the x2 and decrease again and decrease again and go again to the x2 and so on till the counter gonna be 0. It will be moving automatically to the next line. So in this step exactly, R1 gonna be equal to 15 decimal, so 15 decimal, which means it's not 0, so and the decrease jump not 0 condition, it's satisfied, as you can see here, and it will be jump again and repeat it again and again till clean all the wanted memory. And if we want to go to the next step, now after that we need to give specific registers specific values as he asked in the questions. So first of all we need to give 48 decimal to the 2f(x) register, and 45 we need to give it to the 2e hex, and so on. How we can do this? First of all we need to do the same, we need to use the same counter. Same counter is used here because we are using the same registers, so it's our new counter. It's our we gave it again because we need to move it again, we need to move 16 times again to fill the specific registers with the specific data. First, and then in the next line we are giving the A registers, the our accumulator, the value 48 decimal. So this value, our wanted value, we will move it, we will put it exactly in the two F hex registers. So in the next line we are giving the R0. This is the address that we are going to put our specific data. So to FX. See the changes here. So as we saw in the previous label, when it's 16 R1, it's 10 hex. 10 hex, it's all the same. And now move the accumulator to 48 decimal, which is 30. So you can see it from here. We're using the decimal 48, which is 30 hex, as you can see again here. Now in this label we are move at R0 to the accumulator. R0, what it means? Well, it's an indirect addressing. We'll consider it as an address to F hex equal to what? Equal to A accumulator 30 hex, and it's the same like 40 decimal. You can see all the changes from here. If you want to control it, just write now to F hex and notice the change. Okay, look, it's 30 hex, which is 48 decimal. It's all the same. And now we are subtracting from A 3, sorry, now A equal to 45 decimal, which is, it's 2D. Let's see, 45, yeah, equal to 2D. Yeah, that's right. And then decreasing R0, it's our what, or the address. So let's see the new, so it's 2E again, 2E hex, this label, and then decrease, jump, and decrease and jump, if not 0, our counter, which is now 15, and the condition is satisfied, and he will jump again and fill all the wanted memory again and again and again till end of the program. It will be repeated 16 times and fill all the wanted values or data, and after that it will be stopped automatically. Okay, we are now in this first, when it will be end, yeah, and stop. Our last value gonna be in the 20x register, supposed to be 3. You can see here, yeah, it's a 3, as you can see, 3, 6, 9, C, F, 12, 15, 18, 1B, 1E, 21, 24, 27, and so on. Thank you for listening. In this program, he's asking us to write the 8051 assembly program codes to implement required as follow. First of all, is asking to define the numbers of 00D, 02, 65, 07, 4, 162 respectively in the program memory. Simply, it's done by writing downward the program table db and the request numbers like we have done in this step. Download the programs. Let's see the other requests. Then he said add the first number, which means this one, I mean the second number, which means so 0, 1, 2. He's asking us to add 2 decimal with the 65 decimal, which are exist in the table. Download our programs. How we can do that? Let's discover it step by step. After writing or 00 hex is jump start, then starts. Now we need to define the table to the data pointer. After defining the table to the data pointer, this is defined the table to the data pointer. So all the information in the table now added automatically to the data pointer. After adding it, we need to choose to pick the first value of the table, which is exists now in the data pointer, from the table and put it in the accumulator. How we can do that? Now we gave the one hex data to the accumulator. After that, we by doing move CA at A plus dbtr, this means we picked the first value of the table and add it to A, which means now A contains value, and then we moved or we transfer this value, the same value, to the R0 register, which means 02 hex, and then define the second. We need to pick the second value from the table, so we are giving accumulator the 2 hex or decimal whatever to the accumulator and put it again by move CA at A plus dbtr. This means again A equal to the second value 0 1 2, so this one 65 decimal, which means 65 decimal 65, it means 41 hex. So let's move it. Let's add now A to the R0, which is now 2 decimal to the 65 decimal as a decimal, so A equal to 67 decimal, which means 67 decimal, which means 43 hex. Let's run the program to be sure that we are working rightly with no wrongs, and follow the program step by step. As we said, we defined the table to the dbtr, gave A, now we gave A1, so we gave N1, and then we will pick the first value of the program, which is 2, this one. Then we will give A 2 hex and then move it to the table. We are picking the second value, which is 65 hex. It's 65 decimal, which is 40 equal to 41 hex, and everything is right till the moment. And now we are adding A to the R0, which is 2 to the 65 67 decimal, which is 43 hex, and everything is right. And now we are moving. We are just to keep this value because we need to use the accumulator again and again, so we need a register to keep our value. So we are keeping it in R0, we just to keep our value in the register. Now we are giving 3 hex because we need to pick, as he asking now, subtract the third number from the result of B. Now the result of B is already exist in the R0 registers, so first of all we need to pick the third number from the table. So we gave 3 hex to the accumulator, we add it to the data pointer, and now A will be choose automatically a third, so 0 1 2 3. So A gonna be equal 0 to 0 7, decimal, which is the same as hex. Now we are giving the value of accumulator to the R1. So R1 in this is equal to, sorry, oops, okay, 0.7 decimal. And now we are moving R0 to A, because if you need to use this subtract, you are forced to use the accumulator with some kind of register, like 0 or 1 or 2 or 7, etc. So we are retaining now the value of R0. The value of R0, take it all to the register. Now give it to A. Now let's move the program. Now A equal to 3. Okay, now A3, then move it again, and now R1 equal to 0.7D after picking the value and put it in the R1 register. Then R1 here equal to 7 decimal or hex, whatever. And now we are subtracting. So subtracting value A from R1, A equal to 67 and R1 is 7, which means A gonna equal to 60 decimal and R1 0, which means 60 decimal, which is 3C. Okay, let's see if we are right or not. 3C hex. Move it here. Yep, as you see, it's a 3C, the value of accumulator, the new value accumulator after running the B request. So it's the 3C hex. And now we will give this value to the R0 just to keep this value, because we are going to use the accumulator again, because in here he is asking us to multiply the fourth number of the table with the result obtained from C. So first of all, we need to pick the fourth. How we can do this? We are giving the accumulator for data and then put it in the table, which means again A gonna be equal 0, 1, 2, 3, 4, and 0 for decimal, and the same as hex. Now we are moving A to the B, because I will explain it, because when you if you are going to use multiplication, you are forced to use the accumulator with the B register. So we first of all we need to move A to the B register, which means B gonna equal 0 for B decimal, and then we will pick again the value of R0 from here and put it in A, and this is the new accumulator. Let's see, move it here. A gonna be equal to 4, and then B equal to 4, because we moved A to the B register. Then multiply. Okay, let's multiply A and B. Just multiply it. 60 multiplied by 4, A gonna equal to 240 decimal. Let's see how many X, which means, okay, 0.4 multiply by 60, it's 240 decimal, and it's the same as F0 hex, which means it's F0 hex. Let's move and see. Yes, as you can see here, and the value of B of course gonna equal to 0. And now this is a new value of A after doing the multiplication process. the 240 decimal and F0 hex. And now we will put it again in the R0 because we're going to use the accumulator again during the next and last step, because he said divide the fifth number in table by the result obtained from D. As we done before, we are going to give a 5 data and put it again, which means a gonna be equal to 0, 1, 2, 3, 4, 5, 162 decimal. Now we will move it again to be same like previous 162 decimal, which means decimal 162 decimal A2 hex. Move and see. Yeah, A5, then pick it, so it's A2 hex. It will be moved to the B, and now we will give A again the previous value, which is, yeah, this is A now, the accumulator, which is F0. Just move it and see. Yes, this is a new value of accumulator because we take it back from the R0 register, and the value of B now it's A2, and now we are dividing. If you divide it like A 240 divide 162, this one is the value of A, and if you want the value of B, A equal to 1 and B equal to, let's see from the program, for E, of course, hex, and the program is done. And that's all about this program. Thank you for listening and wish you all the best. Thank you very much again.